Hello dears. In today's class, we are going to discuss about the relation between radius of curvature and focal length. In 10th class, you have studied that this radius of curvature and focal length is related by a relation, that is, radius of curvature is double to this focal length, or focal length is half of this radius of curvature. We'll derive that relation. Here you can see a concave mirror. In concave mirror, the reflecting surface is bulged inwards. I hope you know how to identify this radius of, this reflecting surface of this concave mirror and convex mirror. If the reflecting surface is bulged inwards or the reflecting surface is inwards, that is a concave mirror, and reflecting surface is bulged outwards, that is convex mirror. And as per rules, the principal axis is there, and the light ray which is parallel to the principal axis, after reflection it will pass through principal focus. That is the first rule. The light ray which is parallel to the principal axis, after reflection it will pass through principal focus, and according to this laws of reflection, angle I is equal to angle R. You know what is angle I? It is the angle of incidence. Angle of incidence is equal to angle of reflection, where angle of incidence is the angle between the incident ray and the normal, and angle of reflection is the angle between reflected ray and the normal. Here you can see, if we connect the center of curvature and middle portion of this point, here in this concave mirror, we can shade this backside of this concave mirror, and this is the reflecting surface, and here this is the principal axis which connects the center of curvature and this focal length. And when light is incident on this concave mirror, it will undergo reflection and it will pass through this principal focus. And if we connect the center of curvature, you can see this angle of incidence and this is angle of reflection. Instead of that, angle of incidence I and angle of reflection R, we taken as theta. That is what theta is equal to theta. And this angle alternate interior angles or alternate angles. This alternate angle, if this is theta, this angle MCF is also theta. So these two angles are equal. And again, if we consider this one, here the total angle is 2 theta. See here, this angle is 2 theta, which means this angle also will be 2 theta. The both conditions are same, which means if this angle is theta, this angle is also theta. And if this total angle is 2 theta, this angle is also 2 theta. That is angle MFD is also 2 theta. And we are considering tan theta. Tan theta, opposite side divided by adjacent side. So tan theta is equal to, in triangle MCD, consider the triangle MCD, you have tan theta is equal to MD divided by CD, or DC, MD divided by CD, tan theta. And consider the triangle MFD, triangle MFD. Before that, this MD is just a perpendicular which connects the principal axis and the point of incidence. Since this is a concave mirror and you can see a cave, or it's a curved reflecting surface, for that, to apply this mathematics, we are drawing a perpendicular, that is what MD, which is perpendicular to this principal axis. That is what MFD. And in this triangle MFD, you can see this tan 2 theta as what? MD divided by DF. Tan theta is equal to MD divided by CD, and tan 2 theta is equal to MD divided by DF. And again, consider this rays as a paraxial rays, which means this light ray is very close enough to this principal axis. So in such cases, we can consider this tan theta is approximately equal to theta, or this tan 2 theta is approximately equal to 2 theta, which means theta is equal to MD divided by CD, or this 2 theta is equal to MD divided by DF. Here we got theta as md divided by cd, and 2 theta is equal to md divided by df. In this equation, we are substituting the value of theta, that is 2 into theta is what, md divided by cd, which is equal to md divided by df. That is what, 2 into md divided by cd is equal to md divided by df. In both sides we have md, so we can cancel. Therefore, we will get this equation as 2 divided by cd is equal to what, 1 divided by df. Or we can write this 2 as cd divided by df, or this df is equal to cd divided by 2. See the figure. What is this df? df is the distance from the pole to the principal focus, which is known as focal length, and this dc is what, the radius of curvature, which is the distance between this pole and center of curvature. You know the center of curvature and radius of curvature. If we consider the spherical surface, or if the spherical sphere, the center of the sphere is the center of curvature, and the distance between the center of curvature and the pole is what, radius of curvature. In the normal circle, you know, so while considering this center of curvature and radius of curvature, we can consider this spherical mirror as this circle. This is the center C, and this is what, P. This length gives radius of curvature. So substituting the values, that is what, df is equal to cd divided by 2, means df is the radius of, or the focal length, that is the focal length ef, and cd is the radius of curvature r divided by 2, which means the focal length is half of the radius of curvature. So hope everyone understood the portions. Subscribe my channel, keep on watching. We'll see you in next class with another derivation. Thank you.